Find the range of x such that the quadratic function will never touch the x-axis, which means that at any point that touches the x-axis will not included in the range of x. Let's do some math for fun. Today I am going to talk about a little bit special case about quadratic inequality, which is this question. Now this question basically tells you to find the range of x such that the quadratic function y is equal to 2x squared minus 5x plus 2 never touches the x-axis. So if you guys interested in this question, pause the video and try them for yourself. Okay, so let's draw the graph to illustrate the question first. Now let's plot the quadratic function y is equal to 2x squared minus 5x plus 2. So in order to solve this kind of quadratic inequality, we just like roughly sketch the graph. Don't exactly sketch like you know what I'm talking about. Okay, so we will try to graph the quadratic function y is equal to 2x squared minus 5x plus 2. So we will have the y-axis, we will have the x-axis. Now since the coefficient of x squared is positive, so we will got a U shape, and our next thing is to find the root. So how do we find the root? Can we factorize this? Let's say, so let's factorize this thing now. So what we're going to do is we have 2x squared and then 2 and then negative 5x. So x and then 2x, then 2 and then 1, and then negative and negative x, negative 4x, which will lead to negative 5x, which means that this is like factorizable. So this is equal to 2x minus 1 times x minus 2. And then what you're going to do is to find the roots. So we will set this equal to 0. We will find the roots or zeros or x-intercept. So we'll set this equal to 0. And then we will separate the linear factor because we got equal to 0 situation, and then we can finally find the root. So the root of this quadratic function is x is equal to 1 over 2 and 2. So we can just like 1 over 2, not 1 over 3, 1 over 2 and 2. Since the coefficient of x squared is positive, which means that the parabola is a U-shaped curve. So we will just get something like this. Just roughly sketch to illustrate the situation. Now here's the thing. Find the range of x such that the quadratic function will never touch the x-axis, which means that at any point that touches the x-axis will not included in the range of x, which means that I have two cases. It's either going to be bigger than 0 or less than 0, because the question asks to find the range such that it will touch x-axis. Remember, when a function touches the x-axis, that's the same as x-intercept. The point is x-intercept. But what we want to find the range of x such that the range will never touch the x-intercept. So that's why we got two cases. It's either 2x squared minus 5x plus 2 is going to be bigger than 0, or 2x squared minus 5x plus 2 is less than 0. No equal to, because as the question say, find the range of x such that it never touches the x-axis. So what we can do is to solve the quadratic inequality, but actually we don't need because we already plot the graph right here. So 2x squared minus 5x plus 2 must be bigger than 0, which means we need to define the range of x of this curve because it is bigger than 0, right? So for this, it's going to be x is less than 1 over 2 or x is bigger than 2. So this is the first one for this, and the second one for less than 0 situation, which means we need to define the range of for this curve, right? Don't forget about the region that I plot just now. And we need to find, and what we need to is we need to define the region of this curve. So for this quadratic inequality, it is going to be x is in between 1 over 2 and 2. And do we need to find the overlapping region? No, because it's one of the cases, so you don't need to find overlapping region, or rather you can combine the region together so that how to say, you combine the region, don't combine the overlapping region. So our final answer is going to be x is less than 1 over 2 or x is in between 1 over 2 and 2 or x is bigger than 2, and we are done. This is the answer for this question. So what do you mean by the combine the region now? Example, x is bigger than 1 over 2 or x is bigger than 2. So if x is bigger than 1 over 2 and x is bigger than 2, so let's say this is 1 over 2 and this is 2, you will draw a number line right here, and then x is in between 1 over 2 and 2, so this is the second one. Do you think that we can combine? No. And don't think combine overlapping region is the solution. Why? Because if we find overlapping region, which means that we need to find the range of value of x such that it satisfies both at the same time. But in this case, it's one of the cases, so you don't need to find overlapping region, but you can combine the region. So that's why this is your final answer, or else the range of x will be undefined, because there is naturally no range of x that satisfies the overlapping region, because you don't have an overlapping region. And as always, if you guys learn something new in this video, leave a like and subscribe to the channel, and I will see you guys next time.